Hello students, this is Nishant Vora from IIT Patna. I have been associated with askIITians since last 2 years. So today we are going to study about hyperbola. So first of all, I have divided this topic into 4 different parts to make the reading efficient, right? So first part, I will tell you what is the basic definition of hyperbola. Okay, so let's start with the first part, that is definition of the hyperbola. So let's start. Alright guys, so let us start with the topic hyperbola. The first part, that is definition of hyperbola. And under this section, I will tell you, right, introduction to the conic section. Conic section means why does this chapter come under conic section, right? Why ellipse, hyperbola, parabola, all these are called conic section, right? Then I will tell you definition of hyperbola, standard equation of hyperbola. Standard equation we will derive, okay? And then how to plot a hyperbola, right? Tracing of hyperbola, parametric equations, focal distance of a point. So if there is any point on hyperbola, how to find out distance from the focus. And if center is not at origin, in case of hyperbola, how to find out other things like vertex, directrix, focus, all this. Then I will tell you about conjugate hyperbola and at last rectangular hyperbola. These two are the special type of hyperbolas, right? So let us start. Why this is called conic section, right? Circle, parabola, ellipse, hyperbola. Why all these are called conic section? So let us see this video, right? Why the name conic section basically, right? So suppose if I take a cone, and if I cut it out from this section, in this case I will get a circle, you can see in this video, right? And if I cut this cone into from this section, in this case I will get an ellipse, right? If I cut it out from yet another section, in this case I will get a parabola, and from here I will get a hyperbola. Right, so basically I get ellipse, hyperbola, parabola, circle, all these are nothing but cutouts of the cones. Alright, so what is the conic section? Conic section, why the name conic section? Because all these are nothing but, so if we slice a cone at different sections, we get circle, parabola, ellipse, hyperbola. And in this video we are going to focus on the last part, okay, mainly on the last part, which is hyperbola. Okay, so let's start with the definition of hyperbola, right? What is the basic definition of hyperbola? So hyperbola is the locus of a point which is moving in a plane such that ratios of its distances from a fixed point and a fixed given line is always constant, right? So this fixed point is nothing but focus, which is generally denoted by S, and this given line, this fixed given line, is nothing but directrix. Okay, so this fixed point and fixed line are fixed, right? Fixed means they are not moving in the plane, right? But the point is moving. The point is moving such that, right? Now there is another point which is moving such that its ratios of distances from this fixed point and fixed line is always constant, right? So suppose if I take a point P which is moving, right? S is fixed and PM is also fixed. PM is the distance from directrix. So S is fixed, PM is fixed. So P is moving, right? So P is moving such that PS by PM is constant, and this constant is eccentricity. Okay, and in case of hyperbola, eccentricity is greater than 1. You have seen that in case of parabola, eccentricity is equal to 1, and in case of ellipse, eccentricity is less than 1. In case of hyperbola, we have eccentricity greater than 1. So if this fixed ratio is greater than 1, then we get a hyperbola, a hyperbolic curve. Okay, so you can see the diagram here. This is how the hyperbola looks like, right? This is the focus. This point S is called focus, and this point is a moving point which is moving on this curve, right? And this is M. M is the foot of perpendicular on the directrix, right? So this PM is the perpendicular distance from point P to the directrix. So this ratio is always constant, right? PS by PM. PS is to PM is always constant. This ratio is always constant, and it is greater than 1. Okay. Now let us see how to derive standard equation of hyperbola, right? So let me take the point S as the focus and ZM as the directrix. So there is a point S which is focus, and this is the directrix. Okay. Now let me drop a perpendicular from S to this directrix, and let me say this point is Z. Okay. Now since E is greater than 1, we can divide this as Z internally and externally in the ratio E is to 1. Alright. Because PS by PM is E is to 1. Okay. So we can divide as Z internally and externally in the ratio E is to 1. Now let me say that the points of divisions are A and A dash. Right. So this is point A and this is point A dash. A is dividing internally into the ratio E is to 1 as Z, right? So, and SZ is divided externally into the ratio E is to 1 by A dash, right? So these are the 2 points which are dividing SZ internally and externally in the ratio E is to 1. Okay. So now if I take A dash is equal to 2A, if I take this distance equal to 2A, Okay, what will be SA? SA by AZ, right? Because since A point is dividing internally into the ratio E is to 1, so SA by AZ will be E and SA dash by ZA dash will be E. Okay, so these are the two relations that we have. Now, take C as the midpoint of A and A dash, right? So let me take C point here somewhere, which is the midpoint of A and A dash, right? So C is somewhere here. Now, so this is the diagram that we have. This is the focus, this is the directrix. This A and A dash are dividing SZ internally and externally into the ratio E is to 1. C is the midpoint of A and A dash. If C is the midpoint of A and A dash, I have CA equal to CA dash, because C is the midpoint, right? Now, if I add these two equations, this is equation 1 and this is equation 2. If I add these two equations, I will get this, right? Now, SA plus SA dash. Now, SA and SA dash, both of this I will write with respect to center. This C is the center, right? So, I will write with respect to C. Right, so SA will be this distance. SA will be nothing but with respect to center. So CS minus CA, right? So this is CS minus CA. And what will be SA dash? Similarly, SA dash is this distance. So SA dash is CA dash plus CS, right? So CS plus CA dash. And this will be equal to AZ plus ZA dash. So this is nothing but A dash Z plus ZA. So this is nothing but 2A. Right, so E into 2A. So from here we will get CS equal to AE. If I simplify this CA and CA dash will get cancelled, right, because both of them are equal. C is the midpoint. So this will get cancelled. I will get 2CS equal to 2AE. So 2 again will get cancelled. So CS equal to AE. Right, and similarly if I subtract these two equations and again write down SA dash and SA with respect to the center. Okay, if I subtract these two equations, and from here I will get CZ equal to A by E. Okay. Now, so C is the origin, right? Now, if I take C as origin, okay, what is the relations that we have? CS equal to AE and CZ equal to A by E. Now, if I take point C as origin, so this is origin, this is point C. Now, S focus is at a distance of AE. So, this focus coordinates, what will be the coordinates of the focus? Because this distance is AE, right? CS. CS is AE, so coordinates will be AE comma 0. It's lying on the x-axis. This is x-axis and this is y-axis. Okay, and what will be the distance of directrix from the center? Directrix will be somewhere here, and this distance is A by E. Okay, so equation of directrix will be x equal to A by E. Right, so focus will become AE comma 0. Right, so focus will be basically AE comma 0 and directrix will be x equal to A by E. Right. Now, once I have got focus and directrix, I can directly write down the equation of hyperbola by using the definition, that is PS equal to EPM. Right, now P is a point which is moving in a plane, so let me take this P point as some other point, right, x comma y. So PS will be, you can write down by distance formula, this is P, this is S, right, this point is S, so you can use distance formula, so you will get this as PS equal to E into PM. PM will be x minus E. Okay, so now if I simplify this, if I square both sides and simplify, I will get this, right? And in this case, this A square minus E square, A square into E square minus 1, this term I will take as, let this be B square, some other variable. Okay, so I will get the standard equation of hyperbola that we have, that is x square by A square minus y square by B square equal to 1, where what is B square? B square is A square into E square minus 1. Remember, in case of ellipse it was 1 minus E square. Here it is E square minus 1, right? This is in case of ellipse. In case of hyperbola, it is E square minus 1 because E is greater than 1, right? So this is in case of hyperbola. Okay. Now let us see how to plot the graph of this, right? Now since we have got this equation, right, x square by A square minus y square by B square equal to 1, if I look at this equation very carefully, I can observe one thing very clearly, that if I replace x by minus x, I will get the same equation, and if I replace y by minus y, again I will get the same equation. Alright, so from this too I can say that the graph of this hyperbola, graph of this curve will be symmetric about x-axis also, and it will be symmetric about y-axis also. Okay, so graph will be symmetric about x-axis and it will also be symmetric about y-axis. Okay, and if I take the center as 0 comma 0, right, center is at origin, so this will be the graph, right? Here this is the center, this point is the center, this is the two vertices A and A dash that we have already seen, right, A and A dash. So what will be the coordinates of vertices? Vertices will be plus A comma 0 and this will be minus A comma 0. Okay, and what will be the foci? Focus will be, this focus will be A comma 0 and the coordinate of this focus, second one, will be minus AE comma. You can see that the graph is symmetric, right? If this is the y-axis and this is x-axis, see the graph is mirror image about y-axis also, same graph on both the sides, and it is mirror image about x-axis also, right? So whatever is above is below also. So I can just plot the graph in one quadrant and other three quadrants I can take mirror images, okay? And what will be directrix? Directrix in this case will be, there will be two directrix, right? Because I am taking mirror image, okay? So I have one directrix on the right hand side of y-axis, so I will get one directrix here also. Similarly, I will get two vertices, two focus, two directrix, right? And everything will be symmetric, right? Graph is totally symmetric about x-axis also and y-axis also. So foci will be plus minus AE comma 0 and directrix will be x equal to plus minus A by E, okay? Now let us see what are the parametric equations of hyperbola, right? Now to study parametric equation of hyperbola, first of all you will have to learn what is auxiliary circle. Auxiliary circle is this circle which has A dash as the diameter, right? This vertex, the points joining the vertex A and A dash as the diameter, right? So if this is the diameter, if this is the circle which is inscribed inside this hyperbola, touching at both the vertexes, right? What will be the radius? The radius will be A. And what is the center of this circle? Center is at origin. So center is 0, 0 and radius is A. So what will be the equation of auxiliary circle? Equation of auxiliary circle will be x square plus y square equal to A square. So you should always remember that center of auxiliary circle is always same as the center of hyperbola, right? Is always same as the center of hyperbola. In this case, center of hyperbola is at origin. Okay, so center of auxiliary circle will also be origin, right? If center of hyperbola is something else, auxiliary circle will also be something else. Okay. Now what are parametric coordinates, right? So parametric coordinates are the coordinates that will satisfy in the equation of hyperbola, right? So what will satisfy? So if I take theta as the parameter, right? A sec theta and B tan theta, this will satisfy because sec square theta minus tan square theta is 1, right? In case of ellipse we have A cos theta and B sin theta, right? A cos theta, B sin theta. So because that cos square theta plus sin square theta will be 1. Here we have a minus sign in between, right? So we will take A sec theta and B tan theta. Okay, where theta is the parameter. Where what is the parameter? Theta is the parameter. Theta is varying. Right, so previously if I suppose any point on this hyperbola, if I had to suppose any point on this hyperbola, I was supposing as x comma y. Okay, and in this I have two variables, x and y. If I suppose any point as x comma y on hyperbola, I have two variables, right? But if I suppose any point as A sec theta and B tan theta, in this case I have only one variable which is theta. Okay, so this helps, parametric equation helps reducing the number of variables, right? Previously I have two variables x and y. If I suppose this as point P, then I will get only one variable which is theta. Okay, so there is a lot of benefits of using parametric coordinates. Number of variables and number of equations will get reduced, right? Okay, now what will happen if the center is not at origin, right? So if the center of hyperbola is not at origin, let me consider this type of equation, right, of hyperbola, right? In this case what I can do is I can simply take this x minus h equal to capital X and this y minus k equal to capital Y, right? So first of all you convert it to standard form. Okay, so what is the standard form? This is the standard form. So first of all I will always convert it to standard form, right? This standard form, and then I will use the definitions to find out what is center, vertex, directrix and focus. So if I want to find out the center of this hyperbola, right? So what will be the center of this hyperbola first? The standard hyperbola. If this is the equation of hyperbola, then for this equation of hyperbola, what will be the center? Center will be 0, 0, right? We know what are the coordinates of center for standard equation of hyperbola. For this standard equation, center is 0, 0. 0, 0 means capital X equal to 0 and capital Y equal to 0 because everything is in capital here, right? If I am writing for the standard hyperbola, right? So for standard hyperbola, center is 0, 0. So capital X equal to 0 and capital Y equal to 0. Now what is capital X? X minus h, and Y is Y minus k, right? So x minus h equal to 0 and here this will be y minus k equal to 0. So you will get x equal to h and y equal to k. Okay, y minus k equal to 0. So you will get h comma k. So center of this will be h comma k, right? Center of this new hyperbola will be h comma k. Similarly, if I want to find out vertices, what are vertices in case of standard hyperbola? Plus minus a comma 0. This we already know, right? So capital X equal to plus minus a and capital Y equal to 0. So from here again you will find out small x and small y. So you will get this, right? Similarly, what are foci? Plus minus a comma 0. Plus minus a comma 0 means capital X equal to plus minus a and capital Y equal to 0, right? So again you will find out x and y, small x, small y. So you will get this. And similarly with directrix, directrix is nothing but capital X equal to plus minus a by e for this one, right? For standard one, always write down for the standard one and then substitute whatever the values of a capital X and capital Y. Okay. So again you will substitute, so you will get this as the directrix. You will get the two directrix, two focus, two vertices and center. Okay. So this is the method. Understood? Now let us come to the next part, which is conjugate hyperbola. What is conjugate hyperbola? So if the hyperbola whose transverse axis and conjugate axis respectively becomes the conjugate axis and transverse axis of the given hyperbola, right? So basically if I exchange the conjugate axis and the transverse axis, right? So suppose this is the hyperbola. In this case, this is called transverse axis and this is called conjugate axis. This is the normal hyperbola that we have studied right now. And what is conjugate hyperbola? If I exchange transverse axis and conjugate axis, right? So conjugate axis becomes transverse axis and transverse axis becomes conjugate axis. So this hyperbola will look something like this. Okay, so you can say it is kind of a vertical hyperbola, right? So where conjugate axis and transverse axis are interchanged, right? So if I interchange transverse axis and conjugate axis, I get a conjugate hyperbola. Okay, so this is what is conjugate hyperbola. And the graph of conjugate hyperbola will look like this, right? This is the graph of a conjugate hyperbola. It will be like a vertical hyperbola, right? And in this case, how will I find out vertex, center, focus, all these things? In this case, it is very simple to find out vertex, focus and directrix, all these things. Just you should swap x, y, and also you should swap a and b, because we are exchanging transverse axis and conjugate axis, right? So just swap x and y and just swap a and b, right? So what is center? So center of this will be 0, 0, because if I swap xy in 0, 0, it will remain 0, 0 only, right? What is vertex of normal hyperbola? Vertex of normal hyperbola is plus minus a, 0. So in this case, in case of conjugate hyperbola, vertex will be 0, plus minus b, right? Just swap xy and swap ab, right? So a will become b and x will become y. Okay. So what is the vertex? What are the foci? Foci are plus minus a, 0 in case of normal hyperbola. So in case of conjugate hyperbola, we have 0, plus minus be, right? So this is be, 0, b, and this is 0, minus be. Okay. Here similarly it is 0, b, one vertex, and second vertex 0, minus b. Okay. Similarly, b by e is one directrix and minus b by e, y equal to, right? Swap x, y also. So there it was x equal to a by e. So here it is y equal to b by b. Swap x, y, swap a, b. So you will get everything. Okay. And what will be the standard equation of conjugate hyperbola? In standard equation of conjugate hyperbola, you will just replace 1 by minus 1, right? So wherever there is 1, you will just replace by minus 1. So you will get the equation of conjugate hyperbola. Okay, so let us compare these two, right? Hyperbola and conjugate hyperbola. So in case of hyperbola, we have equal to 1, and in case of conjugate hyperbola, this 1 is simply replaced by minus 1, right? Here centers are same. Transverse axis will be y equal to 0 and x equal to 0, right? Transverse and coordinate in this, and here it will just exchange x and y, right? So swap x and y. You will get transverse and conjugate axis of this. Now here length of transverse axis will be 2a, length of conjugate axis will be 2b, right? So again here you can swap a and b, right? Similarly with vertices, with focus and with directrix, this we have already seen. Now this equation will also change, right? In this case I have, what is the relation between b, a and e? Right, here also you will swap a and b. In this case I have b square equal to a square into e square minus 1. So here it will become, in case of conjugate hyperbola, relation will be a square equal to b square into e square minus 1, right? So swap a and b again. Okay. Parametric coordinates, here it will be a sec theta, so here it will become b sec theta. A will become b. If it is b tan theta, this will become a tan theta, right? So swap a and b again. Okay, length of lattice rectum will be 2b square by a in case of hyperbola, and here it should be 2a square by b. Swap a and b again, right? So in this case the length of lattice rectum will be 2a square by b, right? And similarly here also again swap x and y, right? Swap x and y, so you will get the tangent at the vertices also, right? So just you have to remember this thing, that you have to swap xy and you have to swap ab to get everything in case of conjugate hyperbola, right? All this you can find out. Now again a special type of hyperbola, which is rectangular hyperbola, right? So what is rectangular hyperbola? Rectangular hyperbola is nothing but if length of transverse axis is equal to length of conjugate axis. So basically 2a equal to 2b. So 2 will get cancelled, that is a equal to b, right? So if a is equal to b, we will say this is nothing but rectangular. So it is just a special case of hyperbola where a is equal to b. So what will be the equation of rectangular hyperbola? Equation of RH? what is the normal equation of hyperbola? This is the equation, right? Y square by b square equal to 1. Now in this, if I put a equal to b, I will get this. This will be the equation of rectangular hyperbola. Just put a equal to b, right? And if a is equal to b, I can use this relation to find out eccentricity. We have b square equal to a square into e square minus 1. Now in this case, in case of RH, in case of rectangular hyperbola, b is equal to a. So in this, in place of b, I can just write down a, and then I can just cancel this. So basically I will get 1 equal to e square minus 1. So from here I will get eccentricity is equal to root 2. So always remember, eccentricity of rectangular hyperbola is always root 2, right? Any rectangular hyperbola, eccentricity will always be root 2 only, right? So if in the question, if somewhere it is mentioned that there is a rectangular hyperbola which is given, eccentricity will be root 2 simply, okay? And a equal to b, so eccentricity equal to root 2 and a equal to b. These are the 2 points you should remember for rectangular hyperbola, okay? Now let us solve some problems, right? So that you can get a feel of how questions can come, right? So first question is, find the equation of hyperbola whose directrix is given, focus is given, and eccentricity is given. So whenever directrix, focus, and eccentricity is given, what will you think, right? You will always think of the basic definition, that is PS equal to PM, right? So how will I solve this question? I will solve simply this question by using PS equal to PM, where what is P? P is any general point which is moving in a plane such that ratios of its distances from fixed point and fixed line is always constant, right? So S is given, what is focus? 1, 2, eccentricity is given, and directrix is also given. Let me write down this directrix like this. Let me take minus 1, this 1 to the left hand side. Okay, so this is the equation of directrix. So what will be PS? PS, now first of all you square it both sides, right? Square it both sides, because by applying distance formula I will get a root, right? So I am squaring both sides. So here I will get x minus 1 whole square, PS square you can write down by using distance formula, this PS square. So x minus 1 whole square plus y minus 2 whole square, and this will be equal to e square is 3, right? And PM square will be distance of this point from this line. So put this point in this line. So if I put this point in this line, I will get this, and divided by coefficient of x square plus coefficient of y square. This you might have studied in straight line, right? How to find a perpendicular distance from a point to a line. So this will be PM and whole square, right? Now if you simplify this, you will get the equation of hyperbola, right? Now you can simplify this, okay? Let us see one more example. Suppose if the latus rectum of hyperbola is equal to half the conjugate axis, right? So latus rectum of hyperbola is 2b square by a. So length of latus rectum of hyperbola is equal to half the length of conjugate axis. So what is the length of conjugate axis? The length of conjugate axis will be 2b. So this 2 will get cancelled. 1b and b will also get cancelled. So basically I will get 2b equal to a. Right, and what is the equation? I want to find out eccentricity, right? So what is the relation between a, b and e? The relation between a, b and e is b square equal to a square into e square minus 1, right? So b is, now you can just put the value, right? A is equal to 2b, so here I will get 4b square into e square minus 1. Now this b square will get cancelled, so eccentricity square will be 1 by 4 plus 1. So eccentricity you will get as root of 5 by 4. Okay, so from this you can find out the eccentricity, right? Now let us see one more example. If E1 and E2 are the eccentricities of hyperbola and its conjugate, right? So E1 is the eccentricity of this hyperbola and E2 is the eccentricity of conjugate hyperbola. Then we have to prove this. E1 power minus 2 plus E2 power minus 2 will be 1, right? So basically, if E1 and E2 are the eccentricities of this and this, right? What will be the relation in case of hyperbola? In case of hyperbola, I will have this relation b square equal to a square into E1 square minus 1. And in case of conjugate hyperbola, I will swap a and b, right? So basically, I will have a square equal to b square into E2 square minus 1, right? Now from here, I have b square by a square equal to E1 square minus 1, and from here what is a square by b square? A square by b square is E2 square minus 1, right? Now this is equation number 1, this is equation number 2. Now if I multiply this 2, I will get 1, this will become 1 because it will get cancelled. So 1 equal to E1 square minus 1 into E2 square minus 1. Now if you simplify this, basically I will get E1 square, E2 square minus E1 square minus E2 square plus 1 equal to 1. So this 1 will get cancelled, and from here basically you will get e1 square plus e2 square equal to e1 square e2 square. Now this e1 square e2 square you can take it to the denominator, right? So if I take it to the denominator, I will get this, right? e1 square by e1 square e2 square plus e2 square by e1 square e2 square. This is equal to 1. So basically you will get the required, right? e1 power minus 2 plus e2 power minus 2, this will be equal to 1. Got it? So just use the two relations that we have, right? Just you have to swap a and b if it is a case of conjugate hyperbola. So I think this is pretty much clear to all of you, right? So students, till now we have seen what is the basic definition of hyperbola, and we have also seen what is conjugate hyperbolas and rectangular hyperbolas, and at the end we have also solved some questions, right?